Hello guys, first of all I'm going to explain question number 4 for the math 9231 October November 2. Okay, this question is really important. It's worth 10 marks in the first section. It says a toboggan travels along the path ABC shown in the diagram. The path lies in a vertical plane and consists of two circular arcs AB and BC. The arcs are of radius 20 meters and subtended angle 60 degrees at their centers D and E. Okay, respectively, the line ABC is horizontal. The line ABC is horizontal, so we can make a line like this. And there's no friction between the toboggan and the snow, so you can imagine that all of this path is covered with snow. There's no friction. Air resistance is also negligible, and the toboggan may be treated as a particle. The speed of the toboggan is at slowest point is u meters per second. Find the range of values of u for which the toboggan will reach C without losing contact with the snow. Okay, first of all, to find the range values, there is the minimum and there is the maximum. Okay, the minimum velocity, which is the minimum u is required for the toboggan to reach C, is when u is being too small so that the toboggan has insufficient energy to reach the highest point. Hence, we can equate the final velocity at the highest point to be 0. So according to conservation of energy, the total work done is equal to 0. Implies that the change in kinetic energy, implies that the change in kinetic energy is equal to change in K. So I would say that half the mass of the toboggan times the U minimum squared is equal to mg delta H. Here you can assume that here this is considered as delta H. To find this, we make a perpendicular vertical line. This is 20 meters, so this is equidistant, so this is 30 degrees. Implies that the maximum, or you can say that delta H is known as this, delta H is equal to, all of this is their radius, so at the lowest point 2D is 20 meters, so delta H is equal to 20 times big bracket 1 minus cosine 30 degrees. It's simple trigonometry. 20 times 1 minus cosine 30 degrees. This is simply the distance from here to here. if I want to find the change in height between the lowest point and the maximum point, so I must multiply by 2. So this is delta H over 2 plus the delta H is equal to 40 into 1 minus radical 3 over 2. Plug this into our main equation. Cancel out the m's. U minimum becomes radical 80 g into 1 minus radical 3 over 2. This is approximately 10.4 meter per second, taking g as 10 meter per second square. Okay, for the second part, sorry for handwriting. For the second part, the maximum velocity is required when u is being too large, so that the normal reaction at some point between B and C is 0. Centripetal force at B is greatest and the normal component of weight is least. Why is that? Because at any point you'll notice that the normal force is equal to this is assumed to be the vertical, so the vertical component of weight minus the centripetal force. So when the centripetal force is greatest, the normal component of weight is the least, and such that in B the body does not touch it. The body, which is the toboggan, does not touch this point, hence because the normal component is least. So the gravity force is enough to give the body its circular trajectory at that point. Equating at B, if I equate at B the centripetal force, we'll use another color here, use here, oh it's too bright. Here is the centripetal force, and here is the vertical component. The vertical component correspond to the plane, so it's mg cosine 30 degrees. Equating both forces, so you can say that the centripetal force is equal to the weight, so we can say that mv squared over r is equal to mg cosine 30 degrees. So you can say that v square is equal to 20 g, r is 20, so 20 g radical 3 over 2, which is known as cosine 30, plus this is equal to 10 g radical 3. This is v squared. Using the conservation of energy, again, the change in kinetic energy is equal to the change in gravitational potential energy. Whereas the delta H is the same. Here, delta H is not the same, sorry. Delta H is equal to delta H over 2, because from here to here is known as delta H over 2. So half m times u maximum square minus v, which is the velocity at point B, at position B, is equal to mg times delta H over 2. We can cancel these two, and we can cancel these, and implies that u maximum square is equal to v square plus g delta H, which is equal to v square is known as 10g radical 3 plus g delta H. Delta H, we said here, is equal to 40 into 1 minus radical 3 over 2. I will not write it again, so you know the answer here, which this is equal to u maximum, the exact value is equal to radical g into 40 minus 10 radical 3, which is approximately 15.1 meters per second, again taking g as 10 meter per second square. So finally the inequality for u becomes u is greater than 10.4 and smaller than 15.1. All of this will guarantee you the full mark. We'll go to the next part here. The next section says find also the value of u for which the top again will leave this node B and travel as a projectile until it lands again at C. Okay, for top began to travel as a projectile, so this is related to projectile motion. Assume that the initial velocity here, this question is relatively very easy. The initial velocity here, and this is the initial angle, and it travels as a projectile until it reaches C. The initial angle is where you can find it here. Here is 30 degrees, so this 30 degrees implies, and this is 90 degrees, so okay, the initial angle here is 30 degrees, so you can use the well-known trigonometric equation, independent of time. We say that y is equal to x, y is equal to x tan theta minus g x square over 2 u square cosine square theta. When the particle reaches C, y in this situation is 0, there is no increase in height. And the initial angle, or the projectile initial angle, is theta, which is 30 degrees. X, which is the distance between B and C, you can find it easily using also trigonometry. X is equal to 2 sine 2 times 20 sine 30. We will show that this is a triangle, so this is 30 degrees. 20 sine 30 will give you half the distance, times 2 will give you the full distance between B and C. Was that x is equal to 2 times 20 sine 30 degrees. Sine 30 is half, implies that this cancel and this cancel, so the distance between B and C also remains 20 meters, or you can assume that this is an equilateral triangle. Both of them has same sides. Okay, we have here setting this is equal to 0, so you can say that x is equal to 2u square cosine square theta. Theta in this case is 30 degrees, tan 30 degrees over g. So x is equal to 2 u square cosine square 30 degrees tan 30 degrees over g. Okay, plus that x, which is 20, so you can say that you can find out easily u. U in this case will become approximately equal to approximately 15.2 meters per second, which is very close to the maximum value of u calculated in the first section. Goodbye, see you next time.